Hello everyone, this is a video about Ericsson Educate Tech Traveler Game, Mission 4 by Group 7. So in this video, we'll be covering about three topics, which are the amplitude modulation, angle modulation, and radio digital modulation. Amplitude modulation. So what is amplitude modulation? An amplitude modulation is a process by which the amplitude of the transmitted signal is modulated to convey information, usually through a radio carrier wave. This is the general formula of an AM amplitude modulation. We are going to divide AM into two categories, which are the non-suppressed carrier system and suppressed carrier system. Inside the non-suppressed carrier system, we have DSBFC, double sideband full carrier. Usually, the carrier frequency is higher than modulating signal frequency, and the modulation index is given between 0 to 1, where modulation index M is equal to sideband amplitude over carrier amplitude. On the right-hand side, we have DSBFC generator, and on the bottom of it, we have the frequency spectrum. Inside the suppressed carrier system, we have DSBSC, double sideband suppressed carrier. Usually, the carrier component is suppressed, which means that EC is equal to 0. It has two sidebands, the upper sideband USB and lower sideband LSB. It consumes less power due to the absence of carrier in DSBSC. It also provides large bandwidth due to the presence of two sidebands. Again, we can see that on the right-hand side, we have DSBSC generator and also its frequency spectrum. Now, we are going to look at single sideband suppressed carrier, SSBSC. One sideband is suppressed while the other is transmitted. It has narrow bandwidth, thus provide higher power efficiency. Again, we can see that on the left-hand side, we have SSBSC generator, and on the bottom of it is this frequency spectrum. On the last one, we have VSB, vesicle sideband. It is produced by leaving a vestige around 25% of one sideband and all of the other sideband of a DSP signal. The filter design is easy as high accuracy is not needed. The reduction in bandwidth is making it almost as efficient as SSB. Here we can look at the generator, and below of it is the frequency spectrum. For the last part of AM, we are going to discuss about AM signal demodulation. First one, envelope detector. An envelope detector accepts DSBFC as input and provides an output, which is the demodulated envelope of the original signal. While for synchronous detector, DSBFC, SSBFC, and VSB are pass-drift synchronous detector, while low-pass filter is used to retrieve back the original signal. That's all from my part. I'll be passing the video to the next speaker. Thank you.
Hi everyone, I'm Billy. I'm going to explain about the angle modulation. The angle modulation is the process in which the frequency or the phase of the carrier signal varies according to the message signal. This is further divided into frequency and phase modulation. Frequency modulation is the process of varying the frequency of the carrier signal linearly with the message signal. However, the phase modulation is the process of varying the phase of the carrier signal linearly with the message signal. In the frequency modulation, the frequency of the carrier signal varies in accordance with the instantaneous amplitude of the modulating signal. The amplitude and the phase of the carrier signal remains constant, whereas the frequency of the carrier signal changes. This can be better understood by observing the following figures. From this figure, we can conclude that with the increase in amplitude of the modulating signal, the carrier frequency will be increased, or vice versa. The frequency modulation also can be divided into narrowband frequency modulation and wideband frequency modulation. These are the characteristics of the narrowband FM and the wideband FM. For narrowband FM, the frequency modulation has a small bandwidth and the modulation index is small. The frequency spectrum of narrowband consists of carrier, upper sideband and lower sideband. This is used in the mobile communication such as the police, wireless, ambulance, taxi cab, and etc. For wideband FM, the frequency modulation has infinite bandwidth, the modulation index is large, and its frequency spectrum consists of a carrier and infinite number of sidebands, which are allocated around it, and this is used in entertainment broadcasting applications such as the FM radio, TV, and etc. Phase modulation is a procedure in which the magnitude and the rate of change of the modulating signal are used to modulate the degree of phase shift of a carrier. Due to the fact that a change in the phase shift results in a frequency change, the phase modulation causes the frequency modulation. The greater the phase shift is produced by the higher modulation, which in turn results in greater frequency deviation. A bigger frequency deviation and a faster rate of change of the modulating voltage are both produced by higher modulating frequency. The modulating amplitude and frequency have an equal and opposite relationship to the carrier frequency deviation. Positive and negative peaks have the same amplitudes and there is no frequency change during this peak. And this is a comparison between the frequency modulation and the phase modulation. For frequency modulation, the amplitude is constant and independent of the modulation index. The transmitted power will remain constant and independent of modulation frequency. The FM receiver are immune to noise, and the bandwidth of FM is larger. For the phase modulation, the amplitude will change depends on the modulating voltage. The transmitted power dependent on the modulation index, and the AM receiver are not immune to noise, but the bandwidth is less than the FM.
Hi guys, I'm Kai Hong and I will continue our presentation. What is radio digital modulation? RDM is the process of encoding a digital information signal into amplitude, phase, or frequency of the transmitted signal. There are analog and digital versions of the three modulation types, which are ASK, FSK, and PSK. In ASK, the binary signal when ASK modulated gives a zero value for low input while give the carrier output for high input. In FSK, the two binaries that logic low represent low frequency and logic high represent high frequency given a binary signal. While in PSK, the phase of the carrier signal is changed by varying the sine and cosine input at a particular time. So the SK modulator block diagram comprises the carrier signal generator, the binary sequence from the message signal, and the band-limited filter. There are two types of ASK demodulation process. There are synchronous and asynchronous demodulation. The clock frequency at the transmitter matched with the clock frequency at the receiver is known as synchronous method, as the frequency gets synchronized. Otherwise, it is known as asynchronous. Synchronous ASK detector consists of a square law detector, low-pass filter, a comparator, and a voltage limiter. A square law detector is one that output voltage is proportional to the square of the amplitude modulated input voltage. The low-pass filter minimizes the higher frequency. The comparator and the voltage limiter help to get a clean digital output. The asynchronous ASK detector consists of a half-wave rectifier, low-pass filter, and comparator. The modulated ASK signal is given to the half-wave rectifier, which delivers a positive half output. The low-pass filter suppresses the higher frequency and gives an envelope detected output from which the comparator delivers a digital output. The FSK modulator block diagram comprises two oscillators with a clock and the input binary sequence. Following is block diagram. In FSK demodulation, the two oscillators produce higher and lower frequency signals, which are connected to a switch along with an internal clock. To avoid error phase discontinuities of the output waveform during the transmission of the message, a clock is applied to both the oscillator internally. The binary input sequence is applied to the transmitter so as to choose the frequency according to the binary input. The main method of SSK detection are asynchronous and synchronous. The synchronous detector is a coherent one, while asynchronous detector is a non-coherent one. So PSK block diagram. To generate a PSK signal, we need to use a low pass filter and multiplier. To demodulate a PSK signal, a coherent detector must be used. PSK has two types depending upon the phase the signal gets shifted. There are binary phase shift keying, BBSK, and quadrature phase shift keying, QPSK. The table below shows mapping of QPSK signal using gray code. QPSK consists of two BBSK systems which has a 90-degree phase shift between them. Channel I with a phase of 0 and 180. Channel Q with the phase of 90 and 270. In the constellation diagram, there is a combination of BBSK channel I and Q. Note that the QPSK spectrum is half of that of BBSK with the same bit rate. So, what are the features and common applications for this digital modulation? The main characteristic of ASK is more noise will produce but bandwidth efficiency. The main use in low frequency RF application, home automation devices, industrial network devices, and wireless base station. In FSK, less noise will produce a larger bandwidth. They are mainly used for paging communication system, caller identification, utility metering. While in PSK, less noise will produce than SK but with similar bandwidth. They mainly used for wireless LAN, biometric, contactless operation, along with RFID and Bluetooth communication. That's all. Thank you.